Okay, let's just dive right in. I want you to imagine pushing your body way past its absolute biological limit, fighting off the one thing it craves more than almost anything else. Back in 1964, a 17-year-old high schooler named Randy Gardner decided to do exactly that. He wanted to break the world record for staying awake. No stimulants, no caffeine, just pure, unadulterated willpower. Welcome to this explainer on the ticking clock of sleep loss, where we're going to uncover the frankly shocking reality of what happens when we try to deny our own biology. 264, that is the sheer number of hours, literally 11 full days, that Randy managed to stay awake. And look, this wasn't just some fun, quirky experiment. It was a rapid, terrifying descent into complete neurological chaos. By day 3, the guy couldn't even finish a sentence. By day 5, he was fully hallucinating, genuinely convinced he was a professional football player, and by day 11, after 264 hours without a single minute of sleep, he was functionally a zombie. They asked him to count backwards from 100 by sevens, and he just stopped at 65 because he completely forgot what he was doing. Guinness World Records actually stopped tracking this record shortly after because, well, people were literally dying trying to beat it. Section 1. Anatomy of an all-nighter. So let's talk about the terrifyingly rapid cognitive and metabolic decay that sets in when you do this. Look at just the 24-hour mark. Pull a single all-nighter, and your cognitive impairment is suddenly equivalent to a blood alcohol level of 0.10%. You are essentially legally drunk, and your reaction time just completely tanks by 50%. Hit 36 hours, and your hormones go totally haywire. Your body actually stops metabolizing glucose effectively, meaning you are functionally pre-diabetic, and your prefrontal cortex, your impulse control center, it basically just goes offline. By 72 hours, the blood-brain barrier weakens, and your system starts screaming for help. Your brain forces these emergency shutdowns called microsleeps that last about 3 to 10 seconds. Your eyes might be wide open, but trust me, nobody is home. So why does this happen to us? Well, humans are kind of built with a bit of a biological design flaw compared to the rest of the animal kingdom. Take dolphins, right? They can sleep with just half their brain at a time so they don't drown. Frigate birds take these little micro naps while they're literally flying. But us humans, if we try to skip sleep, our brain doesn't just cleverly switch halves, it thermal throttles. It's exactly like running a high-end gaming laptop sitting on a fluffy bedsheet. The fans start screaming, the frame rate drops to single digits, and eventually, you risk melting the entire motherboard. We can't bypass this. We absolutely have to spend a third of our lives in a vulnerable coma just to stop our own brain from poisoning itself. Let's pause the clock for a second and look at the underlying mechanics here. Every single time you think, move, or process a frame of vision, your brain burns fuel called ATP. And just like a car engine, burning fuel creates exhaust. In your brain, this exhaust is a sticky chemical called adenosine. I want you to think of adenosine as physical gum clogging up your brain's gears. From the exact moment you wake up, it's building up, binding to receptors, and actively slowing down your neurons. So you know that incredibly heavy, sluggish feeling you get at around 2 a.m.? That is quite literally a physical chemical sludge dragging down your neural pathways. Which brings us to a truly mind-blowing biological mechanism. When you finally do go to sleep, specifically when you drop into deep, slow-wave sleep, your brain cells physically shrink by an astounding 60%. Seriously, 60%. Why? To create space. They shrink so that cerebrospinal fluid can just flood right into those widened spaces and physically wash away all of that toxic adenosine buildup we just talked about. This whole biological mechanism is known as the glymphatic system, and it acts as the brain's essential nightly dishwasher cycle. And the thing is, it's not just clearing out adenosine. It is washing away other super dangerous metabolic waste products, including a protein called beta amyloid. Now, that is the exact same toxic protein that piles up in the brains of Alzheimer's patients. By getting deep sleep, you are literally running the dishwasher that clears out the biological precursors to neurodegenerative diseases. It's absolutely crucial. And this exposes a really major misconception we have about dealing with tiredness. So many of us think a strong cup of coffee just magically solves the problem. But let's be very, very clear about this. Caffeine does not remove the exhaust. It doesn't run the dishwasher at all. All it does is block those adenosine receptors. Caffeine is basically the equivalent of slapping a piece of black tape over a flashing check engine light on your dashboard. The warning signals your brain is screaming at you are masked, sure, but the engine itself is still totally choking on toxic buildup. Which leads us to a much darker question. What actually happens when that dishwasher stops permanently? Since we obviously can't ethically push humans to the absolute limit of death via sleep deprivation, we have to look back at some pretty morbid experiments conducted at the University of Chicago back in the 1980s. Researchers forced rats to stay awake indefinitely using a rotating disc over water, aiming to figure out the exact lethal consequences of total sleep deprivation. The results were gruesome, and they perfectly detail exactly how sleep loss triggers rapid, catastrophic systemic failure. These rats didn't just get tired, their metabolism absolutely skyrocketed. They were eating twice as much food, yet they experienced rapid weight loss and their fur literally fell out. They developed severe bodily lesions, and within 11 to 32 days, every single rat was dead. But here is the most terrifying part of all this. When researchers performed the autopsies, they couldn't find a single obvious cause of death. Lack of sleep didn't cause just one specific organ to fail. Instead, the rats suffered a catastrophic simultaneous collapse of every single system. It was total organ collapse, simply because sleep is the only time the entire body runs its coordinated repair cycle. Now, translating this dramatic climax into human biology reveals a pretty horrifying picture. When you miss sleep, you aren't just making your brain tired, you're actively wreaking havoc on your entire biological machine simultaneously. This is how sleep loss triggers rapid systemic failure across your whole body. Your cardiovascular system faces persistent sympathetic activation, which means irregular heart rates and spiked blood pressure. Your metabolic and endocrine systems trigger insulin resistance and hormonal imbalances. And your immune system is heavily suppressed, severely dropping its natural killer cell activity. When you rob your body of sleep, you are triggering a synchronized failure across your cardiovascular, metabolic, and immune systems all at the exact same time. Section 2. The fatal insomnia disease. The ultimate, terrifying proof of this absolute biological law is a very rare genetic prion disease called fatal familial insomnia, or FFI. It's carried by only about 40 families worldwide. This mutated gene literally eats holes in the thalamus, which is the part of your brain that acts as the sleep switch. Once the countdown begins, the progression is just relentless. First, patients completely lose the ability to nap and enter deep sleep. Then, massive panic attacks and intense hallucinations set in as the brain stays constantly, artificially wired. Finally, within just 6 to 18 months, this progresses to total dementia, unresponsiveness, and inevitably death. The human body physically cannot endure the slow, unstoppable accumulation of systemic damage. Now, you might be wondering, well, why not just use heavy sleeping pills? The terrifying reality for FFI patients, and honestly a really sobering lesson for all of us, is that sleeping pills do not work. Artificial sedation is not sleep. Sedatives simply knock the body unconscious, but they absolutely do not trigger the glymphatic system or that active coordinated biological repair of genuine slow-wave sleep. So even while chemically sedated, the brain continues to fracture and deteriorate. Every all-nighter is a layaway payment on dementia. That is a chilling thought, right? You might survive pulling all-nighters right now. You might feel totally fine after a weekend of sleeping in and catching up, but the bill is compounding with interest. Sleep is the non-negotiable tax we pay for consciousness, and if you try to evade it, your own biology will eventually come to collect. So, the next time you're tempted to push through the night to meet a deadline or finish a game, ask yourself, is skipping your brain's nightly repair cycle really worth the long-term cost? What are you actually trading away for a few extra hours awake?